In this video, you will learn how to solve a triangle using the law of cosines. Now earlier we looked at the law of sines. Law of sines was really useful when you either know or can find an angle and its opposite side length. In that case, you can use law of sines and that will be more simple. But we obviously don't always have that, and that's when we need to use law of cosines. So let's again take a triangle and use some of our right triangle trig that we learned last unit to be able to discover the law of cosines. So I'm going to start with this left triangle. Again, I have a right angle here, and one thing I want to point out is that because angle A is at the top where I dropped my altitude, from B to C would be side A. So if I want to talk about only this part of side A, I would need some side X in our other triangle to be subtracted from the large side A. So now, let's say that we wanted to solve for side C. If I was to solve for side C, since I have right triangles, I could have used Pythagorean theorem. So let's go ahead and write that out. So I took my hypotenuse squared and set it equal to each leg squared. Now that gave me A minus X quantity squared, because again I had to subtract out the other part of side A that was in my right triangle. So let's go ahead and multiply what A minus X times A minus X would be. That's going to be A times A squared, A times negative X, and another A times negative X, and then plus X squared. And of course we still have the H squared, and all of that equal to C squared. At this point, let's go ahead and now look at Pythagorean theorem for the hypotenuse of my right triangle. And so here the hypotenuse is B, so B squared will equal our H squared plus X squared. Now, if we look back at this other triangle, right now I have an H squared and an X squared being added together. We also, in the right triangle, have the same thing. So everywhere I see H squared plus X squared, I could replace that with B squared. So now that I've rearranged it and made the H squared and the X squared next to each other, I can replace this with what we know it's equivalent to, B squared. Next, we still have this X in there, and we want to get rid of that. So let's go back to, again, our right triangle and see if we could solve for side X. So if I look at the right triangle, if I make angle C theta, B would be the hypotenuse and X would be the adjacent side. And so that means the cosine of angle C would equal the adjacent side over the hypotenuse. If I put that over 1 and again cross multiply, X will be B times the cosine of angle C. Now everywhere that I have X, I can replace it with what we know it's equal to. So let's go ahead and do that. And at this point, we have our law of cosines. If we wanted to solve for angle C, or if we were given angle C, this is the version of law of cosines we would use. There are also, just like law of sines, two other versions, and that's what we're going to look at down below here. So let's say you were given angle A, or maybe you wanted to solve for angle A. The version of law of cosines you would want to use is side A squared equals the other two sides, B squared and C squared, added together, minus 2 times the other two sides, times the cosine of angle A. Again, something to kind of point out is that when I was equal to side A It's the cosine of angle A, its opposite angle that I'm using. So let's say you were given angle B, or you wanted to solve for angle B. The version of law of cosines you would then use is side B squared equal to the other two sides, A squared and C squared, added together, minus 2 times those other two sides, A and C, times the cosine of angle B. Again, you will notice that when I had side B equal, I use the cosine of angle B. And lastly, if I'm given angle C or want to solve for angle C, I'm going to use the version we just did. C squared equals the other two sides, A squared plus B squared, minus 2 times A times B times the cosine of angle C. And again, when I have side C squared, it's going to be equal to the cosine of angle C. So let's now look at the steps we want to go through to actually solve using the law of cosines. Say we're given the triangle below here. Because I am given angle C, that's going to tell me to use the C squared equals. And so if I go ahead and plug in what I know, 9 is side B and A is side 12, I have C squared equals 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of 125 degrees. At this point here, I could go ahead and put all of this into my calculator to get C squared. So let's go ahead and take our calculators out. So again, first thing I want to check on my calculator is that because I'm going to do the cosine of 125 degrees, make sure my mode is in degree mode. Once I verify that, I pretty much just enter everything the way I see it. 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of 125. Now, that gives you, remember, C squared. So at this point, I could say that C squared is about 348.893. But again, we're not interested in C squared. We want to know C. So how do I get rid of the square? By taking the square root. So without clearing out this long decimal, we're going to press second x squared to get the square root. And then I also want to press second again, the negative key, because that has the answer. That will take this entire decimal and put it in underneath the radical. Now when I press enter, I see that side C is about an 18.679. Now, if you remember with the law of sines, we said that we can always check very fast to see if our answer is reasonable because the largest angle should be opposite the largest side length. Here, 125, since it's obtuse, has to be the largest angle, so that makes sense that it's opposite what I can now see as the largest side, the 18.679. Now, just like before though, when we're solving a triangle and only given 3 parts, we need to solve for all 3 parts. And so step 2 is to decide if we know, or if we were given, the largest angle of the triangle. If the answer is yes, you can then use your law of sines to solve for the rest of the triangle, because you now know an angle and its opposite side length. If the answer is no, then you need to be careful. You're still going to use law of sines, but you have to solve for the smallest angle first. If you don't solve for the smallest angle first, you could end up having an ambiguous case, and law of cosines should never have an ambiguous case. So let's write that we never use the law of sines to solve for the biggest angle. So here, again, C is 125 degrees. That has to be the largest angle. So I should be able to do my law of sines for either angle A or angle B. Let's go ahead and do it for angle A. So the sine of 125 degrees divided by what we now know, the opposite side is 18.679, should equal the sine of angle A divided by side A, which is 12. If you cross multiply, we would have that 18.679 times my sine of angle A is going to equal 12 times the sine of 125. Again, I'm trying to get angle A by itself, so that means I need to divide each side by the 18.679. And then I also have to take the sine inverse of each side. And so in my calculator, I want to enter the sine inverse of my 12 times the sine of 125, close parenthesis, 18.679. So second sine, 12 times the sine, 125, close parenthesis, that's very important, divided by 18.679. This tells us that angle A is going to be about 31.7 degrees. To find angle B, again, you can just subtract from 180. And so if you go ahead and do that, you could see that angle B is going to be about 23.3 degrees. Let's now look at the example on the next page. So again, the first thing you want to do, just like with law of sines, is label what you know. I know angle A is 51 degrees. I know that side B is 7. And I know that side C is 10. If I can use law of sines, that's going to be easier. But I only know angle A, and I don't know its opposite side length. Since I only know one angle, I can't do law of sines. So then next I'm starting to think about law of cosines. Since angle A is the angle I know, to eventually be able to do law of sines, I need to first solve for side A. And so that means I need to use the law of cosines for when A squared equals the other two sides squared and add together, minus 2 times the other two sides times the cosine of angle A. So let's go ahead and plug in what we know. A squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 51 degrees. Again, if you're in the degree mode, you should be able to enter this straight into your calculator. And that tells me that A squared is about a 60.895. Again, I want to take the square root of each of these. So second x squared to get square root, and second the negative sign for answer, to get that A is about 7.804. Once I know that, I now know an angle and its opposite side, so I can go ahead and do law of sines. Here though, I have to make sure that I do it for the smallest angle. Now that I know all three side lengths, I can see that 10 side C is the biggest side length. So that means that angle C has to be the largest angle. Never do law of sines to solve for angle C, the largest angle. So I'm going to do my law of sines to solve for angle B instead. So that would be the sine of 51 over my 7.804 I just found. And so then the sine of angle B over side B. Again, you can cross multiply here, and in my calculator, I'm going to be doing 7 times the sine of 51, enter, divided by the 7.804, enter, and here I can do second sine, second answer again, and it looks like angle B is about 44 degrees. If I want to find angle C, again for angle C, I can just take 180 degrees, subtract out the 51 I was given, and the 44 that we just found, and I see that angle C is going to be about 85 degrees. Please now pause the video, set up example 2, deciding which law of cosines you should use, and then see if you can go ahead and plug everything into the equation and solve for that first side. Since you were given angle C, you wanted to solve for side C first. So if I use my law of cosines for angle C and side C, and I go through the calculations, I eventually get a 14.439. At this point again, I want to look at my triangle, and now that I know I have side C to be 14.439, decide what's the largest side. Here that's side A. Since that's opposite angle A has to be my largest angle. So I do not want to do law of sines for angle A. So please now go ahead and do law of sines with your side C ratio to solve for angle B. Please pause the video and complete that. If you go ahead and do your law of sines and solve for angle B, you should have found angle B to be 35 degrees. I can then subtract from 180 the 39 degrees I was given and the 35 we just found to find that angle A was going to be 106 degrees. Please note, 106 degrees is obtuse. So if you had done law of sines to solve for angle A, you would have gotten a value of 74 degrees for angle A. That would have been a two triangle situation, and again, for law of cosines, we should never have ambiguous cases. Please now pause the video and complete example 3. Here, we should have solved for side A first using the law of cosines since we were given angle A. That gave me a side measure of 461.757. Then, looking at all three sides, I could decide that side B was the largest, meaning angle B would be the largest. So I did not want to use law of sines for that because that is the only one that might possibly be obtuse. So I then did law of sines to solve for angle C. When I was done doing that, I took the given measure and my 58 degrees for angle C and subtracted them from 180 to get angle B. Please now complete your homework for tonight.